Welcome back, everybody. In this edition of video, we are going to look at integers and how to add and subtract them. So we definitely want to pay attention to the sign of our numbers. So you'll learn a few tricks along the way of how this could be done, some methods. So eventually we can apply these to real life situations. So enjoy. So one strategy is to use a visual model that every black chip is going to represent a positive 1 and every red chip will be and every pair of these red and black chips are going to be 0 pairs because their numbers are opposites. And remember, all opposites will always add to make 0. So let's use this visual model first looking at just positive numbers. 2 plus 5 equals 7, that's obvious. So 2 black chips and 5 black chips would make 7 black chips altogether. How would this look like on a number line? Well, there's 2 plus 5 more equals 7. And you can count the units here. There's 1, there's 2, there's 1, 2, 3, 4, 5. Of an increase, ends at 7. So that's how you could do it on a number line. The same idea works with negative numbers. -4 plus -2, if you think about it in terms of chip colors, that would be 4 red chips and 2 more red chips. That's 6 red chips altogether, and that stands for the integer of -6. On the number line, we'd start at 0. We'd first go back 4 to represent the -4, plus 2 more negative, so I'm going to go back 1, 2 more, and that's going to end me at the -6. So here is my -4 plus -2, 2 more, and I end at -6. So now we're going to look at some problems that involve both positive and negative numbers. So we want to know and remember that all opposites will be zeros. Whether that's 1 red chip and 1 black, that's a 0. 2 reds and 2 blacks, those are opposites, that's a 0. 3 reds and 3 blacks, that's an opposite, so it's a 0. Or 4 reds and 4 blacks. As long as we have the same amount of reds and blacks, that means we have the same amount of positive and negative, and therefore we have opposites or a 0 pair. So here is such a problem that has both a positive number and a negative number involved in it, and we're going to see how this particular equation equals a positive 2. First in the visual model up above, and then how you could do it on the number line below. So remembering that all opposites are zeros, I could circle up some pairs here and say that these 2 reds and these 2 blacks make a 0 pair. I could say that these 2 reds and these 2 blacks are opposites, so that's a 0 pair. So when I cancel everything out, I'm left with 2 black chips, so that means my answer to this problem is a positive 2. If I wanted to, I could have taken a larger group of integers to make opposites. The -4 and the positive 4, those are opposites, so those are zeros. So what's left over, again, is the positive 2. So on the number line, how would this look? Well, I'm going to start at 0, and I'm going to go back to the -4 to represent my first integer number of -4. And now I'm going to add 6 to that. So I'm going to move in the forward direction 6 numbers. 1, 2, 3, 4, 5, 6, and if you look, I end my line segment at the 2 here. First I went back to the -4, then I went forward a plus 6, and all together I end at a positive 2. So here is a problem that involves some larger integer numbers. A positive 51 and a negative 62. I definitely do not want to draw out individual integer chips for this, and I don't think I want to be counting all of these movements on a number line either. So if we group them into larger numbers, breaking apart the negative 62. This is another way to represent the negative 62. That's negative 50, negative 60, negative 61, negative 62. And positive 51 can be represented as a 50 and a 1 chip. So let's look at my opposites that will cancel each other out. That would be the negative 50 and the positive 50, a negative 1 and a positive 1, and what is remaining is these two guys right here, a negative 10 and a negative 1, and combined that makes negative 11 as the solution here. Another way to think about doing this type of problem without having to do a visual model is just to kind of think about it in terms of chips. Well, this would be 62 red chips, and this would mean 51 black chips. We clearly have more red chips than black chips. So when we start to circle up our zero pairs, we should have more red chips left over. So a quick subtraction of doing 62 minus 51, well, that equals 11. So that means I have 11 extra red chips than black chips. So my answer is going to be negative 11. That's another way to think about that. A lot of math teachers would try and teach you these skills thinking about absolute value on a number line. Negative 62 is 62 numbers to the left. So that has an absolute value of 62 numbers. 51 is 51 numbers to the right. That has an absolute value of 51. So clearly, the negative 62 has a larger absolute value number. So whichever number has the larger absolute value, the answer would take that sign. So negative 62 has a larger absolute value, so our answer is going to take that negative sign. In order to figure out the number part that goes with this answer, well, you simply just take your two absolute values and subtract those to determine the number part. Just like thinking about it in terms of chips and colors, that's 11. That's how we get the number part. So the sign comes from the larger absolute value. The number part comes from subtracting those two absolute values. And that's how you do it. Subtraction, same thing, we can do it with a visual model. 7 minus 2, well, I have 7 chips on the board. I'm going to subtract 2 of these. Clearly what's left is going to be 5. How this would look like on the number line, I'm going to start at 0, I'm going to count up to 7, and then I will subtract 2 by going backwards 2, and you can see that I am now ending at the 5. The same idea works with negative numbers when you're subtracting. If you have the necessary amount to subtract from, you can just do the subtraction. So I start with negative 6, I'm going to subtract negative 5. I have enough chips to do that subtraction. So there's the negative 6, here's taking away 5 of those. And what is left over is just the one red chip, so that stands for negative 1. Subtraction of negatives can be represented on a number line as well. I think it tends to be a little confusing. I would not use this strategy, but this is how that would look. Starting at the 0, subtracting 6 to represent that negative 6, and then to subtract negative 5, that means I'm going to go back and take away 5 of those negative numbers. So 1, 2, 3, 4, 5, and when I do that, I end at the negative 1, just like I did up above. So subtraction is a little bit tricky because it's kind of opposite thinking in terms of movements of left and right on a number line. So I might pick a different strategy here, visual model or something else. Here's where we're going to run into problems when I'm doing something like 4 take away negative 3. I can represent positive 4 as 4 black chips, but how can I take away 3 red chips when I don't have them? We're going to have to put something into this in order to have the red chips to take away. And that can be a little tricky, but this is how that looks. I'm going to put 3 0 pairs into the equation here, and that's going to give me the necessary red chips that I need. Now I have 3 red chips that I can take away. So I didn't change the value of what I'm starting with. This still means +4, and this means nothing. This is a big 0 pair. But when I do this, I now have the 1, 2, 3 red chips that are necessary to remove, and I didn't change the problem. So now I take these 3 away, and what am I left with? It's all black chips, and there's 7 of them. So that's a +7. The same skill or idea can be applied to a number line. I think it's kind of confusing, so I probably wouldn't use a number line in order to figure out a problem like this. So another way to do this is called doing the additive inverse. So on a side note, if I wanted to do 8 take away 2, the same problem could be accomplished by doing 8 plus -2. Both of those expressions start with 8 and are going to remove 2. So what's different? Well, you can see the top one involves subtraction, the bottom one involves addition. So we're changing this to an addition problem, but then we're doing the inverse, which means opposite. This started as a +2, so we make this a -2. So we can use that same idea for any subtraction problem with integers. Change the subtraction to addition and change whatever sign is following that is on that second number, and then you have done the additive inverse. So 4 minus -3, we could do the same thing as saying I want to do 4 plus and change the sign on the next number, make that be a +3. These two problems are exactly the same. They both equal 7. So let's practice the additive inverse. Number 1, -15 take away 12. I could do -15, change it to adding, and do the inverse sign on that following number. So now what I really have is a negative plus a negative, or red chips plus red chips. That's just going to be a -27. Okay, I wouldn't do that on a number line. I would think about it in terms of, colored chips. Number 2, -25, take away -30. That can be kind of confusing, so to make it be addition, I can start with my -25, change it to an adding problem as long as I change the sign on the next number. The additive inverse. Changed it to adding, did the inverse or opposite sign. That type of movement in math is always going to be acceptable. So now I have one negative number and one positive number. So whatever strategy you would use here would be fine. I might think about this on a number line, or you could think about it in terms of colored chips. You'd have 30 black chips and 25 red chips. Well, I got more black chips than I do red chips. So I have actually 5 more black chips, so my answer is a +5. Or think about it on a number line. -25, that's 25 numbers to the left of 0, so it has an absolute value of 25. And 30 has an absolute value of 30 numbers, that's to the right. So this number has the larger absolute value, so the answer, we'll take the sign of that, so that's a positive. I usually don't write a little plus, it's just extra to write. So the answer is positive. And how positive is this answer? Well, just take your 2 absolute values and subtract them. 30 minus 25 is 5. The answer is 5. Understanding integers, it takes time, it takes practice, but if you put the effort in, you will be an expert in working with integers.